nuclear fusion reactor created by school teenager successfully achieves plasma. And this kind of echoes everything else that I've been saying. A student has successfully deployed a small nuclear fusion reactor as part of his A-levels. The 17-year-old built the reactor to generate neutrons as part of his extended project qualification. Hello, Inspired Earth. I hope that you guys are having a great week. We have a lot of stuff to cover with this episode. It's going to be kind of a roller coaster, up and down, and then at the end we have some pretty crazy rescues, so if you want to stick around for that, that'll be good. So we're going to talk about PFAS in the Air Force at the very beginning, to just briefly go over that and then skim over some news with outer space, and then come back to the planet, and then we'll talk about alternative energies in the future. So we got a lot to talk about, and we'll go ahead and just jump straight in because we have so much. And we'll talk about Air Force avoids PFAS water cleanup, citing Supreme Court's Chevron ruling. So what was it, late June, the Supreme Court overturned Chevron doctrine. Air Force bases contaminated the water with toxic PFAS forever chemicals and other dangerous compounds. So this was the conservative-dominated U.S. Supreme Court. It says in the article, though former U.S. Environmental Protection Agency officials and legal experts who reviewed the Air Force's claim say the Chevron doctrine ruling probably would not apply to the order, the military's claim that it would represent an early indication of how polluters will wield the controversial court decision to evade responsibility. It appears the Air Force is essentially attempting to expand the scope of the court's ruling to thwart regulatory orders not covered by the decision, said Deborah Ann Sivas, director of Stanford University Environmental Law Clinic. It is very odd, she said. It feels almost like an intimidation tactic, but it will be interesting to see if others take this approach and it bleeds over. The Supreme Court in late June overturned the 40-year-old Chevron doctrine, one of its most important precedents. The decision sharply cut regulators' power by giving judges the final say in interpreting ambiguous areas of law during rulemaking. Judges previously gave deference to regulatory agency experts on such questions. So this can be both good and bad, the Chevron doctrine. Basically, when it's talking about experts here, the judges in the courts had to go by what the experts say. So, like, we're talking about science and stuff that people don't know much about. So it's important to have science and experts tell us what the truth is. But here we are again with the downside to this, that was some of these experts, or quote-unquote experts, were being paid to give testimony by these corporations. So I see both sides of the law, but I don't have a law to like say what we should do or anything like that. I don't have a legislation written up to say what we should do, but this was both good and bad, this order. But now that they've undone it, they can just go buck wild. I mean, they pretty much already were, and that's like this is just very nuanced and confusing, but and you can tell because it's the Air Force versus the EPA, which we'll go into here. I'm just going to skip to the bottom of the article because above is just like a bunch of details. You're more than welcome to click on the article and read. I'll link it like usual. In a formal response sent to the EPA in the weeks after the Supreme Court reversed Chevron, the Air Force claimed the EPA lacked the authority to make the order, citing the case as evidence and stating the EPA's order cannot withstand review. But legal experts noted that Chevron does not affect EPA enforcement. Actions like the Tucson order, it only affects the rulemaking process. So the Air Force doesn't even understand what they're talking about. law, or I mean, this order that the EPA is giving out is not affected by any sort of. They're not making a law. They're not trying to make new laws, writing legislation. So they've already given the order. So there's no intersection where this Chevron decision could change the outcome of. The laws have already been written, and they're just enforcing the laws at this point. So this Chevron decision is at the writing and legislation level, as far as I can tell, and we're past that. The laws have been written, and the Tucson, or the order, has already been given. So this is past the point of them being able to stop this. But moreover, one arm of the administration cannot sue the other. So the military cannot sue the EPA, and the case would never end up in court where the Chevron decision would come into play, said Walter Mugdan, a former EPA Superfund director. Instead, it would be resolved internally by a presidential administration instead of the judiciary. So I guess the president will decide, which don't have very much hope in that. But it is interesting that it would never go to court, and that this defense that the Air Force is trying to bring into this is like a court defense tactic, but it's never going to go into court, so their tactic doesn't work. It doesn't apply in multiple levels. So what are they even doing? It's just kind of embarrassing for the Air Force, frankly. However, a business that finds itself in a similar position may try to sue the EPA. So great job, Air Force, for showing them that they can do that. The Air Force did not respond to specific questions about its Chevron claim, but said it will continue to meet our obligations under the federal Superfund law. The crux of the rest of the Air Force's refusal to comply with the orders hangs on whether there is imminent, substantial danger to Tucson, Arizona residents. The Air Force noted Tucson's drinking water was currently below the federal limit for PFAS, but our cities here in Texas are not, so what are they going to do about that? And regardless, they'll continue on here, but the EPA noted the filtration system was straining because it was not designed for PFAS, and the plume was especially dangerous because there are limited alternative drinking water sources in the desert. The real possibility that the system breaks and leaves people exposed or without clean water constitutes imminent and substantial danger, the EPA wrote in the response. And that's totally true. In the middle of the desert, there's not that many drinking sources. So if this filtration system breaks and a huge plume of PFAS goes out, it's going to go from well to well to well and spread out under the ground. And then it's going to affect everything because there's nothing else. The law does not require or expect EPA to wait until people are actively being harmed. In fact, Congress expects the EPA to utilize its authority to prevent the harm from materializing. So there you go, Air Force. The Air Force also claimed it should not be forced to address the problem because the city of Tucson and state of Arizona are funding a different system to address PFAS. In response, the EPA said the new system would not be ready for years, and the Air Force is financially responsible for the pollution. The Air Force bears responsibility for the PFAS contamination and needs to step forward to protect the Tucson community, the EPA wrote. And that's the end of the article. That was The Guardian, which is a British newspaper. A lot of times I have to go to other sources outside of the United States to give us reporting on stuff going on inside of the United States, which I consider that to be shameful. But yeah, we'll follow up on this story. This is kind of a developing story. The Chevron doctrine, I don't even know what to say about that. We'll just see what continues to happen. But new findings with the moon. I'm sure a lot of you guys already saw this. So they found caves on the moon, which, if anybody saw the lunar episode that I did, the lunar photos episode, I talked about caves on the moon in that episode. So for them to be like, oh, wow, we found all these caves. Yeah, we've known that there's caves. I mean, many people have said that there's caves on the moon and Mars. But I guess it's the size of this one that they were struck by. It says that it's more than 200 feet from the base, and that the pit is located 230 miles northeast of the first human landing site on the moon. The full extent of the cave is unknown, but it could stretch for miles beneath the mare. So a lot of these are supermassive, and if the ceiling of the solidified lava tube collapses, it opens like a pit, like a skylight, that can lead into the rest of the cave-like tube. And there's a video that NASA posted. I'm not going to play it because it has a lot of music, and yeah, you can't really do that with YouTube. If it was just them talking, then I could do it, but they have a lot of music in it. But I'll post the link like usual. But basically, they're saying that there was molten lava beneath the moon, and that these tubes of lava came to the surface and spilled out, is their theory for how these were made, which is fascinating. But yeah, a lot of them I think have been used for stuff. We'll see in the coming months and years of China coming to the moon and America coming to the moon, or whatever happens. We'll find out what's there, I guess, hopefully. But here we have Mars. Well, actually, I'll put this one in a different order. China's lunar lander finds more evidence of water on the moon. So we'll stick with the moon real quick. With high latitude mineral samples obtained by Chang'e 5's mission, which found 40% water molecules. And I'm probably mispronouncing that name, but they found a new material that could be used for nuclear fusion, they said, and then water, and specifically, according to the paper, these ULM-1 samples contained about 41% water molecules by weight. That's pretty significant. The samples were also taken from a much higher latitude than regions targeted during the other water-seeking missions, like NASA's SOFIA Stratospheric Observatory for Infrared Astronomy flight in 2020, or India's Chandrayaan-1 probe in 2009. And then we just canceled our Viper 1, which I think I have something about that later on, but if not, you know, we had a lunar rover we were building for a long time. I can't remember how many hundreds of millions of dollars, or we definitely put many millions of dollars into it, and we canceled it at the last second. Now they're throwing it out to the commercial field of who can try to save this mission, apparently, but they don't know anything about anything. They were saying that it might come back to being nationalized because of China's success in outer space. Which, why won't we cooperate with them? That is something that really frustrates me, is that we will not cooperate with China. We absolutely, vehemently refuse to cooperate with China, pretty much in any regard. And I just find that to be very frustrating. We could do a lot more in space together than fighting each other. But the discoveries of these persistent water molecules follow Chang'e 6's earthly return last month. After launching on May 3rd, Chang'e 5's successor landed on the previously unexplored far side of the moon and drilled a 6.6 feet hole into the Apollo crater. So here we go. We'll go with Mars could have oceans worth of liquid buried in its crust. August 16th. Astronomy.com. Deep beneath the surface of Mars lies a reservoir of liquid water, according to seismometer data and NASA's retired InSight lander. The findings, published August 12th and Proceeding of National Academy of Sciences, hint at a sufficient water to fill oceans and globally cover Mars to a depth of over 1 mile. The entire planet of Mars, underwater by over a mile. But the reservoir will be of little help to Martians Mark Watney or other human explorers. It lies in minuscule cracks and pores in rock deep beneath the planet's crust, between 7.1 and 12 miles under the surface. This means that the underground reservoir is unreachable, at least for now. but this study is the best evidence to date that vast reservoirs of Martian water, most of which was thought to have evaporated into space billions of years ago, may have instead gone underground, raising hopes in search for life. It also opens a window into the planet's past, adding a rich corpus of evidence that billions of years ago water flowed abundantly on Earth's next-door neighbor. That bygone world was warmer, wetter, and girdled by a thicker atmosphere than the desiccated, sub-freezing, and radiation-mauled wasteland of today's Mars. To understand how the world disappeared, a fuller understanding of the Martian water cycle is critical. A useful starting point is to identify where water is now and how much is there. Wright and colleagues, Michael Manga of UC Berkeley and Matthias Morsfield of Scripps, employed a mathematical model of rock physics identical to methodologies used on Earth to map underground aquifers and oil fields. This results suggests and cites seismic data is best explained by a layer of fractured igneous rock saturated with liquid water embedded in the middle of the planet's crust. Establishing that there is a big reservoir of liquid water provides some window into what climate was like or could be like. During Mars' Nochian geological epoch, 4.1 to 3.7 billion years ago, roughly contemporaneous with the stirring of life on Earth, an ocean perhaps filled a third of the planet's northern hemisphere, and conditions may have been habitable. Mars may have had a hydrological cycle similar to Earth's, in which groundwater was connected to rivers, lakes, and possibly oceans. Today, traces of that aqueous past are everywhere. Outflow channels, gullies, dried up riverbeds, and minerals and rocks that could only have formed in water's presence. But impaired by its low gravity, lack of magnetic field, and fierce solar wind, much of Mars' early atmosphere is thought to have escaped into space, along with the water. For decades, the only water accounted for Mars was in the form of ice in the polar caps and buried underground. But recent research has questioned whether Mars lost as much water as scientists thought. An analysis of data acquired from several Mars missions published in Science 2021 suggested that over 30% of Martian water might have remained entrapped in minerals in the planet's crust. There is a lot of uncertainty in how much water was lost to space, but the amount we infer that has been lost is much larger than the volume of the ice on the surface. At the same time, observational evidence has been mounting that Mars harbors a substantial amount of subsurface water in liquid form. In 2018, researchers analyzed data from Europe's Mars Express orbiter, reported what appeared to be a 12-mile salty lake situated 0.9 miles under the South Polar Cap. A follow-up study in 2020 with more advanced techniques bolstered the case and found additional briny areas nearby, and geological evidence from Mars hinted at a planet-wide groundwater system that flourished 3.5 billion years ago. That's pretty fascinating. Makes me think of a couple episodes ago we did the quote-unquote underground ocean that we found on Earth. So, like, I don't know, how did we know about this on Mars, but we didn't know about it? Like, if you remember at the beginning of this article and some of this other stuff, it's talked about for decades we've known that there was Mars on water, or there was water on Mars. And now here we are saying that we've like confirmed it some more with a planet-wide groundwater system that apparently we also have found on Earth. How did we not know that this is going on in either planet? It's just shocking to me of this quantity of stuff that we do not know. That I feel like we should know. That should be obvious. How did we not know that water was going underground on Earth? That just seems so obvious. But I guess it's not. The craft, though, was equipped with instruments and sensors designed to probe Mars' interior. And InSight's ultra-sensitive seismometer, the French built the seismic experiment for interior structure, the SEIS, yielded the data that produced the new results. Capable of detecting vibrations as soft as a breeze, the dome-covered sensor was placed on Mars' ochre-hued surface by the lander's robotic arm. Data was gathered from December 2018 until the mission's end in December 2022. The findings rest on InSight's measurement of the density of the layer of rock beneath the craft and speed of seismic waves produced by Mars quakes and impacts. But if dynamics of the crust are similar all over Mars, there ought to be more than enough water in this mid-crust reservoir to fill the planet's ancient oceans. From what data we have elsewhere on Mars, there's no clear reason to think the mid-crust elsewhere is much different than from beneath the InSight. If there is groundwater below InSight, we would expect groundwater elsewhere too. How the water found its way so deep remains unclear, but its presence is another line of evidence for Mars' watery past. The interior of Mars has been cooling over time. The water is liquid now. It could have been liquid in the past. To get from the surface to these shallow depths, the shallow crust must have been warmer. It also raises the possibility that the deep beneath the surface, the porous saturated rock teems with microbes. Water is necessary for life as we know it. It's certainly true on Earth. Deep, deep mines host life. The bottom of the oceans host life. We have identified a place that should, in principle, be able to sustain life. So, they're saying that there's probably life on Mars. Again. Okay, so we have an update on the over 1,000 earthquakes that has happened in Texas this summer. We are not even through the summer, and yeah, we'll let it play.
The state of Texas has registered over 1,000 earthquakes. A few of the stronger ones, magnitude 4 and above, made headlines in late July. The large number can seem staggering, but the majority of the earthquakes are small and can't be felt. Now, what's even more shocking is that this seismic activity is largely due to unnatural circumstances. Alejandro Savallades is a seismologist and research professor at the University of Texas, and he explains this phenomena is the result of oil and gas production and something we may need to plan for in the future.
We have been pretty, I would say, lucky because all those magnitude 5 earthquakes that happen, most of them have happened in areas that are away from urban environment. For prevention and the situation as we currently have to work with is that we have to monitor the seismicity, try to see where the earthquakes are migrating, and try to see what are the measures that we can use coordinating and collaborating with the industry so that we can avoid the big magnitude earthquakes.
Savallades added that Texas may eventually benefit from a seismic code or guidelines that protect buildings and people from earthquakes, similar to what California has in place.
So the guy said that we need to work with our politicians to do new legislation to change the building code so that we can have buildings that will survive these earthquakes that will become common due to big oil destroying the subsurface infrastructure, I'll call it. I don't know if infrastructure is the right word. It's probably not the right word, but they're destroying the underground stuff where we live. And he also was saying that we should go and ask the big oil companies if they could come up with some sort of way to limit the earthquakes, and that we've been lucky. He said we have been lucky. We've had 1,000 earthquakes, over 1,000 earthquakes in the summer, and he said we've been lucky. Why? Because there hasn't been one that's hit a major city yet. Even though San Antonio got hit with a 4.5 or a 5, over a 5, I think. Maybe not this year, but in the last couple years, I would say that's pretty major. So he thinks that we should go and beg the oil companies, like on our hands and knees basically, for them to just throw us a bone to limit the amount of severe earthquakes that they will make common in Texas, rather than coming up with some other form of energy that doesn't require us to destroy the land that we're living on in more ways than I can even describe. We destroy the land that we're living on with this technology. And rather than just change the technology, we're just going to try to build our building stronger to endure the earthquakes. This is a joke. This is shameful, and it's extremely frustrating. That's pretty upsetting. But actually, there's another article that kind of links back to this again later on. So we'll just move on for now. This is the beginning of the roller coaster downward, right? I said this is going to be a roller coaster. So I hope everybody is locked in, ready to go down the deep slide. So scientists sound the alarm after making concerning discovery about cooling power of the sea ice. We could be missing a considerable part, and I'll just skim through some of this, but this was an article published on earth.com. I'm reading it from Yahoo, but after analyzing satellite images from a 43-year span, scientists at the University of Michigan revealed the devastating impact of rising global temperatures. So what's happening? A group of scientists compared satellite measurements of cloud cover and solar radiation reflected by sea ice from 1980 through 2023. They found that the cooling power of sea ice is not as strong as it used to be. According to the findings, Arctic sea ice has lost about a quarter of its cooling power since 1980. Warming temperatures and increasing rainfall have both contributed to the decrease in the ice's cooling powers, according to the researchers. On top of melting and shrinking ice and shrinking in size, the sea ice is also becoming less reflective. The changes in the Antarctic Sea since 2016 boost the warming feedback from sea ice lost by 40%. By not accounting for this change in radiative effect of sea ice in Antarctica, we could be missing a considerable part of the total global energy absorption. Why is sea ice's cooling power important? Sea ice plays an integral role in balancing the Earth's temperature. When the sun's rays reflect off of the surface and back into space, it creates a cooling effect on the planet. Without this, temperature will continue to rise. This change also affects marine ecosystems in the Arctic and Antarctic. Sea ice is a key habitat for organisms such as polar bears and seals. When ice melts and shrinks, organisms lose key sheltering spots, potentially disrupting the entire food chain. What's being done about decreasing sea ice? In order to spread climate awareness and catalyze action for change, scientists are continuing to study the importance of sea ice. By providing evidence that indicates sea ice is losing its cooling effect, researchers hope policymakers will make the necessary changes to address global temperatures. So that's what's being done. They're studying the ice and they're hoping. That's what it is. Study and hope. That is what our action is right now. And we're hoping that the policymakers, who all of their policies and decisions are inhibited on the manufacturing of money, and will it make profit? So go and ask yourself this, will this sea ice stuff make profit? I don't think that we need to have all of our policies based on profit, but that's where we are right now. So we need to address where we are as a system, that everything is profit-based. And I just needed to point that out, that they're waiting on the policymakers, and the policymakers are all inherently trying to stack fat stacks, as the kids say, trying to get rich. So we need a policy that will save the sea ice, that will make them rich. if possible, or just change the system. But so here we'll go into this next one that kind of reflects the last couple, and it is The Guardian again. We should have had better answers by now. Climate scientists baffled by unexpected pace of heating.